Welcome back. In this video, we're going to go over scientific notation, which is a way of representing numbers that are really large or really small. And this way of representing numbers is often seen in the sciences. So let's take a look at scientific notation. So first of all, definition. A number in scientific notation looks like a number A multiplied by some power of n. So A times 10 raised to the n power. And there's some restrictions here on A and n. For this, n is an integer, so a positive or negative number, no decimals or fractions. And a has to be in between 1 and 10, including 1, but not including 10. So it could be as small as 1 and up to, but not including 10. So 9.999 and change, right? So a is in between 1 and 10, could be as small as 1, has to be less than 10. That's the limits on a, and n is an integer. So it's basically a number in between 1 and 10 multiplied by some power of 10. And so the X that you're seeing in here is really the cross or the times sign that you learned in grade school. It's kind of customary to use this symbol in scientific notation, even though elsewhere in algebra we typically don't use that because we use X's for variables a lot. And so nobody wants to see us write 2 times X like that, right? Because that's just terrible. But in the context of scientific notation, that's the way that you do it, is you use the cross for times in this context. Okay, so examples of numbers that are in scientific notation, 2.16 times 10 raised to the third power, 5.0167 times 10 raised to the minus 2 power. Those two numbers are in scientific notation. These two numbers are not. 0.33 times 10 to the second power isn't, and 50.167 times 10 to the fifth power also is not. What makes these not in scientific notation is the fact that the A here in the first case is 0.33, which is less than 1. And then in the second case, 50.167 is bigger than 10. So that makes these not in scientific notation. Of course, others not in scientific notation would have some non-integer exponents. So if you add 5.6 times 10 to the 0.4 power, or 6.1 times 10 raised to the square root of 2 power, or some kind of crazy thing like that. So we're not going to have that. Scientific notation, the exponent is just an integer, okay, a positive or negative number with no decimal or fraction to it. The a, again, needs to be at least 1 and has to be less than 10. Okay, when you're looking at a number in scientific notation, the exponent is a positive number when the number is greater than 1, and it's negative if the number is less than 1. So 2.16 times 10 to the third power is a number that is bigger than 1. 5.0167 times 10 raised to the minus 2 power is a number that is less than 1. When representing numbers that are big, like astronomical numbers, things like that, you're likely to see big positive exponents. Tiny numbers like molecules and atoms and whatnot would have negative exponents. Okay, so we want to first be able to write numbers in scientific notation from our regular, what we'll call standard notation. So if we're going to write each of these numbers in scientific notation, that means that we need to adjust the numbers so that the decimal point, instead of being after the last digit, in this case on the 96,000 is after the third zero, we need to make it so that it is our A is in between 9 and or 1 and 10. So I'm going to have to move the decimal point 1, 2, 3, 4 places to the left because I need my A to be 9.6. 9.6. It can't be 0.96 because that's less than 1, and it can't be 96 because that's more than 10. It has to be 9.6. So we've moved the decimal point 1, 2, 3, 4 places to the left. And so we'll have 9.6 times 10 to the fourth power. Okay, so that represents our 96,000 in scientific notation. Notice here we divided 96,000 by 10,000, moving the decimal point 4 places to the left, And so to compensate, we multiplied by 10 to the fourth power, which is 10,000. Okay, 48,300, we'll have to move the decimal point 1, 2, 3, 4 places to the left. This will give us 4.83 times 10 to the fourth power. So once again, we've moved the decimal point 4 places, so we have times 10 to the fourth power. Okay, 0.0052, this time we're going to be moving the decimal point to the right by 1, 2, 3 places to make it look like 5.2. We're going to make it times 10 raised to the negative 3 power. Notice on this number we have a negative exponent, and that's because when we put this into scientific notation, we had to multiply by 1,000. We moved the decimal point to the right by 3 places, which multiplied the number by 1,000. To compensate so that we're not actually changing the value of the number, we multiply by 10 raised to the minus 3 power, which is 1,000. Okay, let's try 0.78 next. 0.78 will be 7.8. And we had to move the decimal point 1 place to the right. So this will be times 10 raised to the minus 1 power. If you have trouble figuring out whether it should be a positive or negative exponent, remember that the exponent's positive when the number is greater than 1, and it's negative when the number is less than 1. So 0.78 is less than 1. It's going to have a negative exponent. 0.0052, less than 1, has a negative exponent. 96,000 and 48,300 are both definitely bigger than 1, and they have positive exponents. Okay, 0.0129 will be 1.29 times 10 raised to some power. We need to move the decimal point 1, 2 places over. Our original number was less than 1, so it's going to be times 10 raised to the minus 2 power. Okay, here are a couple for you to try. Right, so take a minute and convert 6,149, 503, and 0.0016 and 21.49 into scientific notation. So at this point, pause the video and try that, and then restart the video and see how you did. Okay, so let's try each of these now then. So 6,149 will be 6.149. I've had to move the decimal point 1, 2, 3 places to the left. This will be times 10 raised to the third power. 503 will be 5.03. We had to move the decimal point 1, 2 places to the left, so times 10 raised to the second power. 0.0016, we're moving the decimal point to the right this time. 1, 2, 3 places, giving us 1.6. So that'll be 1.6 times 10 raised to the minus 3 power. 21.49 will be 2.149 times 10 raised to the first power. Okay. So hopefully you're getting a little more comfortable with that. It does take a little bit of practice. Make sure that you remember that numbers that are greater than 1 will have a positive exponent, and numbers that are less than 1 will have a negative exponent. All right, here are a couple of numbers where we have the number in scientific notation, and we want to convert it back to the regular decimal or standard form. So for this one, we have 1.3 times 10 to the third power. This will be a number that is bigger than 1. So we'll change this to 1300. So the decimal point started off between the 1 and the 3. It'll move 1, 2, 3 places to the right, giving us 1,300. 9.025 will be moving the decimal point 1, 2, 3, 4 places to the right, 90250. Okay, the next two numbers are both less than 1 because they have a negative exponent, so they're kind of small. So 8.9 times 10 to the minus 2 power, this will be 89. The decimal point is between the 8 and the 9. I have to move it 2 places to the left. So 2 places to the left will give us 0.089. 1.2 times 10 to the minus 4 power we're going to have to move this to the left a few places. So let me put in some zeros so I can count across. 1, 2, 3, 4 places. That will give us 0.00012. 7.5 times 10 to the second power. Right now, the decimal point was between the 7 and the 5. We're going to multiply by 100. So that moves the decimal point to the right by 2 places. Okay, there's a couple I've done. Next, we'll have a couple for you to try. For each of these, we're going to convert them from scientific notation to standard form. So let's say 1.46 times 10 to the second power, 3.07 times 10 to the minus 2 power, and then 5.031 times 10 to the third power, and then one more. Let's do 6.1 times 10 to the minus 3 power. Okay, let's take a minute, pause the video, and convert each of these back to our standard form, and then restart the video and see how you did. Okay, so let's take a look. 1.46 times 10 to the second power. We have 146. The decimal point was between the 1 and the 4. We're going to move it to the right 2 places. This will give us 146. 3.07 times 10 raised to the minus 2 power. This is 307. The decimal point is between the 3 and the 0. We're going to move the decimal point to the left by 2 places. So 1, 2, that will give us 0.0307. 5.031, that's 5031. We're moving the decimal point from between the 5 and the 0, 1, 2, 3 places to the right, giving us 5031. 6.1 times 10 to the minus 3 power. We're going to move the decimal point 3 places to the left, 1, 2, 3 places to the left. That will give us 0.0061. All right, so we've practiced converting to and from scientific notation. What's next to do is to see examples of where this scientific notation is actually useful. So where it's useful is doing multiplications and divisions, really. Not so much addition and subtraction, but when you're multiplying and dividing numbers that are really large and really small, scientific notation can be very helpful. So here, if we're going to multiply 3 times 10 to the 6th power times 2 times 10 to the minus 8 power, we can use the rules of exponents that we learned to help us with this. For this one, since it's basically our first one, I'm going to show the steps that we have. 3 times 10 to the 6th power. I'm going to write this kind of the way that we normally would write multiplication, by putting it next to something in parentheses and eliminating that cross sign for multiply. This is multiplied by 2 times 10 raised to the minus 8 power. Multiplication is commutative, right, and associative, so we can write this as 3 times 2, and then we'll have 10 to the 6th power times 10 raised to the minus 8 power. This will give us 6 times 10 raised to the minus 2 power. Okay, so we saw that we multiplied together what I was calling the A's, the 3 and the 2, and then we added the exponents, because what's going on right here is we're using the rule that says x to the a power, x to the b power is x raised to the a plus b power. When you're multiplying, you add exponents together. So where this is valuable, as you can see, is representing these two numbers in scientific notation. The multiplication is going to be easier looking. Let me write this out how it would appear in standard notation. All right, so this is how it would look if we were going to do this multiplication with the two numbers in standard form. And there's just too many zeros there. It's really error prone to do it in that way. And even if you could do it right, it's going to be unpleasant. So scientific notation, the way to go. Here we have 9 times 10 to the 3rd power divided by 3 times 10 to the minus 2 power. So for this one, again, we'll divide 9 by 3, giving 3. and then times 10 raised to the 3 minus negative 2 power. So we're dividing, so we're subtracting exponents. That's 3 times 10 to the 5th power. Okay. Again, that's simple with the numbers in scientific notation. All right, here's an example where the numbers are not in scientific notation, and so it's going to be easier on us to put them in scientific notation, do the calculation, and then if we have to, we'll convert them back. All right, so 0.0000142, I need to put that in scientific notation, so it'll be 1.42. Remember, the A is always between 1 and 10. So to get there, I had to move the decimal point 1, 2, 3, 4, 5 places. So that's times 10 to the minus 5 power. 0.0002, there, that's 2 times 10 raised to the 1, 2, 3, 4, minus 4 power. Okay, so now we can multiply these two numbers together. 2 times 1.42, that's 2.84. It's easy to multiply 1.42 times 2. And then we'll have times 10 raised to the minus 9 power. Okay, and that is going to be way simpler than had we tried to do this with all the zeros involved. Okay, so that takes us to the end of that example. We have one more to do. For this one, we have 93 million divided by 3,100. And so while this one wouldn't be too bad to do using standard notation, we're going to again use scientific notation to help us get this done. 93 million, this would be 9.3 times 10 raised to the 1, 2, 3, 4, 5, 6, 7. We can't check that again. It was here. 1, 2, 3, 4, 5, 6, 7. 9.3 times 10 to the 7th power. And then we're going to divide that by 3,100. That's 3.1 times 10 raised to the 1, 2, 3 power. Okay, now we can divide 9.3 divided by 3.1 is going to be 3. And then 10 to the 7th divided by 10 cubed, that's 10 to the 4th power. But we can change that back. That will be 30,000. 1, 2, 3, 4 places. So that would be 30,000. All right, that takes us to the end of our look at scientific notation. We saw that it's a way of representing really large or really small values. And the advantage to representing them, aside from saving writing when there's 27 zeros, aside from saving writing where you don't have to write all the zeros or count them, it makes multiplication and division with these numbers easier when they're really small or really large. Okay, that takes us to the end of this section. Let me know if you have any questions, and have a great day.